Hello and welcome. In this video lecture, we are going to talk about the concept of heat engine. So first of all, let us talk about why do we need heat engine? Let us say we want to generate power. So how do we generate power? Using electromagnetic induction. So let us say we are having an armature coil present under the effect of magnetic field. So when this armature coil is rotated, what will happen? The magnetic flux through this coil will change, due to which an EMF will be induced. But our key objective is to rotate this armature coil. So what I do, basically I couple this particular system with a shaft. Shaft is a mechanical component which is used to transmit the rotational motion, which is useful in transmitting the power. So if I am able to rotate this shaft anyhow, then I will be able to rotate this armature coil, and thus we will be able to produce electricity. So this is our main objective. So how we are going to rotate the shaft is the key importance here. Now what I do, basically I create a turbine here. These are turbine blades. What we need to do is basically to rotate this turbine. If this turbine starts rotating, then this shaft will also start rotating, and due to which this particular armature coil will also rotate. So at the end we are able to produce a rotational motion in this particular coil, and thus we will be able to generate electricity. So if I ask you, how can we do this? How can we rotate this turbine? You must have heard of hydraulic dams, basically hydraulic power plants. Other power plants are thermal power plant, good, and the other one is nuclear. Fourth one is gaseous, the gas power plants. Now these are certain ways of producing the power. But how actually we are attaining these things? So the key objective is to rotate this armature. And how we are going to obtain this? Let us see. Now if I talk about the hydraulic power plants, in which, let us take the example of Bhakra Dam. What we generally do, we store water at some good height and let water fall, and we generally create this potential energy into kinetic energy of the water. This is generally achieved using the help of a nozzle. Nozzle helps in increasing the kinetic energy of the system, due to which if I place a turbine here, then what will happen? The water will start impinging on this and transferring momentum, due to which this turbine will rotate, and thus this shaft will rotate, and then the armature coil. So we are able to rotate this armature coil. This is what actually is happening in hydraulic power plants. But what are basically the thermal power plants? So it is really important to understand this concept. Let us say I am having liquid, that is, for ease I am taking water. It is in the liquid state initially. I have done some processing, and then later on I have converted into steam, let us say vapors. So my dear friends, what I would have done in achieving this, I basically added heat to the system. Let us say I have added the heat and the temperature has rise to T1. Now what I will do, I will expand this particular state of steam. I will pass this state or the steam through a nozzle. See guys, I am not telling about or just going into the details of different type of nozzles like converging nozzle, converging diverging nozzle. This is a simple nozzle I am considering without any sort of density loss or other things. This is simple nozzle, and what will happen at the outlet of this nozzle? See, initial conditions, initial input of this particular nozzle was this, and at the output the temperature of the steam will decrease, but the kinetic energy would have increased. So after passing through the nozzle, the kinetic energy of the steam has increased, and now if I place a particular turbine here, what will happen? The steam will start rotating this turbine, and This turbine will start rotating the shaft and the armature coil is also getting rotated. So this is the entire scenario. But now comes the most important statement, that is Mr. Kelvin's statement, Kelvin uncle's statement. He stated that it is impossible to convert entire amount of heat energy into mechanical work. This is of great importance. Basically, in any case, we will not be able to convert the entire amount of heat energy into mechanical work. We need steam to be get rejected, otherwise the steam will get collaborated or it will stagnate at a particular point, which will be bad for the system. So actually what happens, some amount of the steam or the heat input which we have given is converted into mechanical work, and other part is get rejected to the surrounding, q rejected to the surrounding. And as I have mentioned that after the nozzle, the temperature also decreases. So let us assume that the outlet temperature is T2. Now, coming to the heat engine, what we have done is basically we were having a particular fluid at temperature T1, then we did some operation and converted it to the temperature T2. And in between this we have obtained a mechanical work. Okay, this is the entire heat engine. Now you guys are going to tell me the direction of flow. See, in case of water power plants or in case of hydraulic power plants or in dam systems, potential difference was created because of height. Here in heat engine, what actually is happening, because of temperature difference, that is T1 minus T2, the heat transfer taking place from upper direction to lower direction. Okay, so on its own I have not provided any sort of system to this particular part, so that the heat must flow from T1 to T2. It is flowing on its own. So this entire system is basically heat engine if the heat is flowing from T1 to T2, and some of the work has been used to do and some of the heat has been used to do some mechanical work. This is basically a heat engine. So if I define it, let us talk about simple engine first. Simple engine is a system which helps in converting one form of energy to mechanical energy. So what can be heat engine? Yes, heat engine is the system which converts heat energy to mechanical energy. This is basically a heat engine. So dear friends, if I have to find the efficiency of this particular system, eta, what we can write? Basically, efficiency is what we obtain, yeah, what we get divided by what we have given to the system. So my dear friends, what actually we have given to the system? Heat input. But what actually we have obtained? The mechanical work. Mech work divided by total heat input. Now this is the efficiency of a heat engine. This is efficiency of a heat engine. I hope it is clear. And my dear friends, it is impossible to convert the entire amount of heat energy to mechanical energy. So therefore, please note this subtle point that efficiency of heat engine can never ever be equal to 1. Always it has to be, eta has to be less than 1. So that's it for the day. If you are having any sort of doubt, then please let me know in the comment section below. If you like the video, then please like, share and comment, and also subscribe my channel. Thank you so much for watching. Take care.